air conditioning with no compressor, evaporative cooling with vapor recovery. In 1758, before the American Revolution, American founding father Benjamin Franklin and British chemist and physician John Hadley conducted an experiment demonstrating refrigeration by evaporative cooling in England. This simple experiment, currently completely overlooked and neglected, will be addressed shortly and, more importantly, improved upon in ways never taught, suggested, or practiced. The invention relies heavily on the work of Franklin and Hadley. That demonstration is well documented, including by Franklin's own account in his own words. Using a mercury thermometer, they measured the temperature of liquid ether in a bowl. It was 65 degrees Fahrenheit, 18.3 Celsius, room temperature. They then took the thermometer out of the container. Some of the ether clung to the bulb and quickly evaporated, lowering the thermometer temperature by several degrees. In Franklin's own words, the wetting was then repeated by a feather that had been dipped into the ether when the mercury sunk still lower. We continued this operation, one of us wetting the ball and another of the company blowing on it with the bellows to quicken the evaporation, the mercury sinking all the time till it came down to 7, which is 25 degrees below the freezing point when we left off. This was his letter to a friend. The experiment may be illustrated like this. Please note, they did not use an electromechanical compressor. They had no electricity. They did this in 1758, and it remained for Michael Faraday of England to effectively discover the principles of electric current almost a century later in 1831. What would you, the reader, do if, right now, wherever you are, presumably inside a building somewhere, air at 7 degrees Fahrenheit started coming from the HVAC duct into your room? The temperature dropped to 7 degrees Fahrenheit, a fall of 58 degrees Fahrenheit from ambient, and 25 degrees below the freezing point of water. Franklin wrote, "From this experiment, one may see the possibility of freezing a man to death on a warm summer's day if he were to stand in a passage through which the wind blew briskly, and to be wet frequently with ether, a spirit that is more inflammable than brandy or common spirits of wine. But ether's not needed. Water will also work, removing body heat, but since it does not evaporate as fast as ether, it will take longer." It is interesting to this writer that Franklin conducted this experiment in 1758. Only 3 years earlier, in 1755, William Cullen of Scotland did a similar thing. Cullen put ether in a bell jar and pulled a vacuum over it with the suction pump. This lowered the air pressure, accelerating the evaporation of the ether. A small amount of ice formed. Cullen never capitalized on his invention. So this is a case of two men working independently on both sides of the Atlantic, producing significant refrigeration using entirely different methods. Franklin using evaporative cooling, Cullen using an early form of vapor expansion and compression within a span of only 3 years. That may be interesting, but here's the strangest part. Of the two methods, Franklin's evaporative cooling and Cullen's vapor expansion, only the latter, vapor expansion, has completely dominated the entire refrigeration market, not only in the United States but worldwide. Franklin's invention has languished in obscurity, hidden in only a few history books. There is a single limited application for Franklin's concept of refrigeration using evaporative cooling. The concept of cooling by evaporation is ancient. Franklin's concept has been updated in today's evaporative cooling systems for sports, sometimes called sports misters. Here, water is substituted for ether and electric fans are substituted for bellows. Here's an example of a sports mister. There are many available. This one claims to drop the temperature from 10 to 20 degrees. Here's another larger, more powerful example. Except for outdoor sporting events, sports misters, this simple process is not currently used for commercial or residential refrigeration indoors. This despite the plain facts that it obviously worked and still works, lowering the temperature from 65 to 7 when used with ether, and it uses no electromechanical compressor. Electric motors were not discovered until 1831, and no working fluid. One may reasonably ask, why? The main reasons we do not see this in use today indoors are that it increases indoor humidity. Indoors, where would the moisture-laden vapor, the result of the evaporation process, go? Excess humidity and moisture are already problems, especially in the South. Indoors, it leads to respiratory problems and black mold. No building here needs additional water vapor inside or in the crawl space or attic, especially in the long summer. It also requires a continual supply of water, and no one has given this much thought to its use within a building. This is the essence of invention. It is the object of this invention to produce cooling and refrigeration without an electromechanical compressor. Again, here are the reasons why this has not been implemented. Of these reasons for failure to implement, the first two may be overcome if we implement a vapor recovery system. Let's examine this more closely. Here is a working model demonstration unit. The biggest part is a styrofoam picnic cooler turned upside down with its top removed with two holes drilled in either side of it. There's a small electric fan, a small bowl, a cotton washcloth, a bottle of isopropyl rubbing alcohol, a 4-inch diameter dryer vent conduit, which is flexible, and a flat metal base plate. This is a small electric fan, a small bowl containing a cloth and liquid alcohol, a dryer conduit, the round shiny tube, all covered and sealed by the white insulated picnic cooler turned upside down, resting on a flat metal plate. The fan, cloth moisture pad, and working fluid, rubbing alcohol, are sealed within the vessel. The fan blows air across the moisture pad, damp with alcohol, accelerating evaporation, absorbing heat, and leaving cool air behind. The cool air sinks down to the metal plate, and the warm, alcohol vapor-rich air is blown out the conduit to the right. As the warm, alcohol vapor-rich air continues through the conduit, it gives up or rejects its heat to the air surrounding the conduit. The air re-enters the picnic cooler from the left side, and the process and the cycle repeat. Here's the sequence. The cotton cloth acts as a large wick for the liquid alcohol in the bowl. The fan blows air across the wick, accelerating the evaporation of the alcohol, just like blowing out a cup of hot coffee. This evaporation absorbs heat, leaving cooler air behind. The warmed air is forced through the conduit to the area outside the cooler or outside the house. That warmed air in the conduit gives up or rejects the absorbed heat to the area outside the picnic cooler or the house. The now cooled air within the cooler sinks down because cool air sinks, cooling the metal plate on which it rests. The cool air from the plate falls to the living space below it, and the process repeats. Here is the abstract from the patent application describing the process in one paragraph. I will not read it for you. In this room, a large air conditioner compressor is installed on the building roof above the black unit below. This compressor is a known energy hog. With this invention, evaporative cooling with vapor recovery, all that's needed is a fan, a moisture pad, and some smaller ducts. The duct absorbs heat from the ceiling, leaving cool air behind, and rejects that heat to the area outside the room or outside the building. Fans are much cheaper to buy and operate than air conditioner compressors. This process has pending patent applications, both United States and international (PCT). By producing refrigeration without a compressor, this process can accelerate the condensation of water vapor in the air into dew in usable quantities, such as for irrigation. When installed near a body of salt water, the condensate is salt-free. This is therefore a desalination process. When installed over a body or stream of polluted, contaminated water, the condensed dew is largely contaminant-free and clean. It is distilled water. This is air conditioning with no compressor, evaporative cooling with vapor recovery. Patents pending. For more information, please contact John at lookforthepower.com. Thank you.